Today we're talking about divisibility by 3, or a trick to tell whether a number is a multiple of 3. If you have a positive integer n, if that's equal to 3 times k, where k is also a whole number. And we'll talk about remainders a lot today. So this is equivalent to saying that when you divide by 3, your remainder is 0. So the steps for this: add the digits to get a new number. And then your new number, you might not know if it's divisible by 3 still, but it will be smaller. So you're just going to repeat that process. Keep adding the digits together to get a new number until you get a one-digit number. And then you just have to check if that one-digit number is divisible by 3. That would mean if it's a 0, 3, 6, or 9, then the original number is divisible by 3. If not, then the original number is not divisible by 3. So add all the digits together and keep adding the digits of the new numbers that you get until you get a one-digit number. If that number is divisible by 3, if it's a 0, 3, 6, or 9, you're good. If not, you're not divisible by 3. So let's see a few examples. First, if we take the number 2,746, is that divisible by 3? Well, maybe you don't know by looking at it. So what we can do is add the digits together. 2 plus 7 plus 4 plus 6, and we'll get 19. Maybe you know that 19 is not divisible by 3, but we can continue the process if not. We'll see that 1 plus 9 equals 10. We can go one more time if we want to. 10 is 1 and 0, so 1 plus 0 is 1. We got a one-digit number. It's not a 0, 3, 6, or 9. So our original number was also not divisible by 3. Let's see a different example, this time with 5 digits. 13,947. Let's add the digits together. 1 plus 3 plus 9 plus 4 plus 7. And we'll get 24. Again, if you can stop here, if you know that 24 is divisible by 3, then you're done. But let's continue until we get a one-digit number. Add them together. 2 plus 4 is 6, which is divisible by 3. So that means that the original number, 13,947, was also divisible by 3. Okay, so to understand why this works, we'll need to talk about remainders. When we're dividing by 3, what that means is we take out as many 3s as possible. This is like when you're doing long division, dividing by 3, what your remainder would be there. And there will be several things to keep in mind when you're working with remainders. The first one is, by definition, you always need to reduce to 0, 1, or 2. Okay, what that means is if you have 25, that's equal to 3 times 8 plus 1. The remainder is 0, 1, or 2, so we're done. The remainder is 1 in this case. If instead we only took out 6 copies of 3, 25 is 3 times 6, that's 18, would have 7 left over, we're not done. Because 7 is at least 3, so 7 is not the remainder. We need to take out 3 twice more and get back up to what we had above. The remainder is 1 when we divide by 3. Now, in order to understand why this trick works, we'll need to be adding numbers and seeing what happens with their remainders. So if you're adding, all you have to do is add the remainders, then reduce. For example, if we have 11 plus 17. Now we know that that's 28, which is 3 times 9 plus 1. The number left over is 0, 1, or 2, so that means that the remainder is 1, and we're good there. But we don't always know what the numbers we're adding are. When we're working with proofs in math, it'll have to work for any number that fits in the category. So we have to show that it works even if we don't know what the numbers are. I'm still going to use this one as an example. This is not a formal proof, but the formal proof would look very similar to this. So 11 is 3 times 3 plus 2. And 17 is 3 times 5 plus 2. So when we add these together, well, we have 3 times 3, 3 times 5, that's 3 times 8. And then we add over the remainders of each of them, plus 4. We're not done. We need to reduce this. When we do, we'll get 3 times 9 plus 1. Just as before, the remainder is 1. Now, when we're multiplying, it's similar. Just like when we were adding, we added the remainders then reduced. When we're multiplying, we're going to multiply the remainders, then reduce. Let's use 11 and 17 as an example again. 11 times 17. Now, on the one hand, we know that this is 187, which is 3 times 62 plus 1, which means that the remainder is 1. But let's see that you can just multiply the remainders and that works. 3 times 3, 11 is 3 times 3 plus 2, times 3 times 5 plus 2. To multiply these, we need to FOIL or distribute twice. So we'll get 3 squared times 15. That's multiplying the first of each part. Multiplying outer, 3 times 3 times 2. Multiplying the inner, 3 times 5 times 2. And then at the end, the last, we have 2 times 2. So if you notice, all of this stuff before where we multiplied the remainders has a 3 in it. 3 squared, 3, 3, and only the stuff at the end, the 2 times 2, might not have a 3 in it. So whatever this thing is, we know that it's 3 times x, 3 times some number. When we're calculating the remainder, we've already taken out all those 3's, so this part doesn't really matter. All that matters is the remainder at the end, which is 4, except we have to reduce that. We take out one more copy of 3, and we have a 1 left over. Just like before, the remainder is 1. Okay, so with remainders, always reduce it to 0, 1, or 2. If you're adding, add the remainders. If you're multiplying, multiply the remainders. Let's see how this works and explains why our trick for knowing if a number is divisible by 3 works. It comes down to the fact that we use a base 10 system. It's 1, 10, 100, 1,000, 10 to the a, which is a 1 followed by a zeros. These are the place values of the numbers, the 1's place, the 10's place, and so forth. And we're going to notice this pattern. 1 minus 1, well, that's just 0. 10 minus 1 is 9. 100 minus 1 is 99. 1,000 minus 1 is 3 9's, just like we had 3 zeros. 10 to the power of a minus 1 is a 9's altogether. And what do we notice here? Well, when I subtract 1, 0, well, that's 3 times 0. 9 is 3 times 3. 99, 3 times 33. 999, 3 times 333. A 9's is 3 times a 3's. In any case, when we subtract 1, the number that's left over is a multiple of 3. Which means if we didn't subtract 1, we get the fact that for any positive integer a, 10 to the power of a minus 1 is a multiple of 3. Which also means that if we add 1, remember we add remainders, 10 to the power of a minus 1 has a remainder of 0. If we add 1 and just take 10 to the power of a, when we divide by 3, that has remainder 1. So it doesn't matter if you're in the ones place, the tens place, the hundreds place. Each of those place values has remainder 1. So let's see why this works, how this explains our trick. If we take the number that looks like an A, a B, a C, and a D, and find the remainder. Well, this number A, B, C, D, it's not A times B times B times C. It's really the A is the thousands place, the B is the hundreds place, the C is the tens place, and the D is the ones place. Now, what we're seeing is we're taking A multiplying by 10 to the 3. We're taking B multiplying by 10 squared. And we're adding up all these pieces together. We're adding and multiplying integers. So when we're finding remainders, when we're trying to find if it's divisible by 3, we're using the same rules as before. If we want to find out what the remainder is of each part, we're going to multiply them. So I'm going to write an equal sign with 3 lines. This means is congruent to when we divide by, in this case, 3. So A times 10 to the power of 3, whatever A's remainder is still A's remainder. And this is being multiplied by the remainder of 10 to the power of 3, which we saw above is 1. And we're going to add that to B times 1 because the remainder of 100 when we divide by 3 is also 1, plus C times 1 plus D times 1. And of course, when you multiply a number by 1, nothing changes, so this is just A plus B plus C plus D. So that means that when we divide by 3, when we're looking at the remainder of our original number, that's the same as the remainder of A plus B plus C plus D, which is going to be a smaller number. When we add the digits together, it has the same remainder. And if we're not already at 1 digit, we can just repeat, and it'll still have the same remainder. The remainder is always the same, so it doesn't matter how many times you do it. Whether the original number was divisible by 3 or not, is going to be the same as the number you get at the end. Okay, so for our exercise, we have 2 this time, exercises. The first is to show a similar trick with 9. And so dividing by 3, we had a trick to do that. With 9, it's similar, and you can show it in a pretty similar way. And so work on that. The second one is, we only actually proved that this works for a 4-digit number. And so if you want to challenge yourself, show it works for an n-digit number, meaning there are n digits where n could be any positive integer. Okay, thanks.